to respiratory system. I know a lot about this because recently I've had fluid on my lungs. Uh, my lungs have been damaged from my arthritis. I have pulmonary fibrosis, chronic inflammation, and hypertensive arteriopathy. So take care of your lungs, don't smoke. Hopefully, we'll be ready to get rid of climate change because extra heat and extra dust is going to be a factor for all your lives. Uh, so vote, and pay attention. So you should know all of these parts. Uh, nasal conchae help the air swirl around and get warm, and there's mucus in there. It helps trap dust. The very, very fine alveoli, the little sacs that are in the lungs, are surrounded by blood pressure. So every time you breathe and air comes into the lungs, oxygen diffuses into the blood and CO2 diffuses out. The small little sacs are called an alveolus. Okay, so there'll be questions about these in WebAssign. So the nasal conchae, they're there to have the air swirl and get warmed up. Your external nares is the opening in your nose. So make sure you go through all of these terms and see where they point to and understand what they do. So they're self-explanatory. A lot of it's just naming, and air will come into here and go down the trachea. You have to have a flap, the epiglottis, to keep food out of the esophagus. Okay, so the respiratory epithelium that lines your nasal cavity, and its job is to secrete mucus and to sorry, and pick up mucus and dirt and get rid of it. Okay, so the respiratory epithelium is covered with cilia. That cilia will sweep the mucus out, and you may swallow some mucus, but you may have to clean your nasal cavity and blow your nose and so on. So the larynx and vocal cords. So here's your trachea. Here's the thyroid cartilage. The epiglottis is the flap that covers your esophagus. So everybody knows there are times when food gets in our esophagus and we cough it up. So just use these terms to answer questions in WebAssign. Okay. Here's another view, posterior view. The vocal cords are behind the thyroid cartilage. The trachea has cartilage to help make sure it stays open. So the vocal cord is in the larynx. You have a false vocal cord. These parts of the vocal cord vibrate, and it allows us to produce numerous frequencies and control loudness and everything. So it's just amazing, the power of speech and how complicated it is and how we learn so quickly. And I have a new granddaughter who's about 2 weeks old, so I'm hopefully going to see her today. Sorry, I'm yawning. I don't know why. Okay, so if you look at a shot of the vocal cords and so on, you can see the view from the top. The epiglottis is there to keep food out of the esophagus. We look at the trachea again. The trachea has cartilage surrounding it and mucus glands, and the esophagus is dorsal to the trachea. So the epiglottis is going to close this to make sure food doesn't go down that. So you have primary bronchi, secondary bronchi, and air flows through the trachea, down the primary bronchi, down the secondary bronchi, and get to the alveolar sacs of the alveolus. And it's very important because without oxygen, well, we need it. We have to get rid of CO2 also. So if you look at the continuation beyond the secondary bronchus right here, you have tertiary bronchi. Notice they're splitting and getting smaller and smaller. And you have bronchioles, terminal bronchioles. And so those that go into the alveolar sacs. So we have many, many, many alveolar sacs. So don't smoke, take care of your lungs, exercise, use your oxygen, and be thankful for your healthy lungs. Okay, so notice that the pulmonary artery comes into the lungs. It's close to the bronchioles, and there's nerves, there's red blood cells in the arteries, and there's veins. There's smooth muscle around the bronchiole, terminal bronchiole, that allows constriction. And sad to say, when people have asthma, there's a problem with the constriction caused by the contraction of these muscles. Asthma can be caused by inherited factors, but also by pollen and pollutants and so on. I hope nobody has asthma, but all of these are surrounded by elastic fibers, and their amount of time and when they're open is controlled by that. So if we look here, we have the parietal pleural, you have the pleural cavity, and the visceral pleural. So just like the heart, you have two layers and a cavity. This visceral pleura is right up against the lungs. The lungs are attached to these visceral pleura, and somebody's coming in. So let's go ahead and admit. Okay, back to the PowerPoint. So the whole purpose of the lungs is to have a blood supply to control air getting into the lungs and for oxygen to go into the arteries and CO2 to leave the veins and go into the alveolar sacs, so that when you breathe out, you're going to go ahead and expel CO2 and bring in oxygen. So again, note this parietal pleura, which is the outside wall around the lungs. Then you have a cavity. That's where I had fluid in here. And the visceral pleura is the wall of the lung that surrounds all the lung tissue. And the lung tissue is intimately connected to this visceral pleura. So the whole purpose of the lungs is to get air into the bronchioles from the bronchi and allow oxygen to be taken up by the arteries and CO2 to move from the veins into the alveoli. And then when you breathe out, you're going to get rid of CO2 and bring in more oxygen when you breathe again. This is a fine picture of that structure. These are alveolar sacs, which contain the alveolus. The alveolus is each small sac. The alveolar duct goes to the alveolar sac. And notice you have connective tissue, elastic fibers, smooth muscle, and capillaries and veins. You can look at this is a scanning electron microscope. So you have thousands and thousands of these alveolus, the little sacs that allow air to be exchanged to bring in oxygen and to get rid of CO2. If you look at this diagram now, we have Notice that the blood vessels are very, very close. Here's the red blood cells, and I'm sorry, that's the capillaries. Those are capillaries. Okay, so the air is in the alveolus, and there are elastic fibers. There are cells that secrete surfactant to keep your lungs open. There's alveolar macrophages, which go around and get rid of any dust or foreign objects that get into your lung sacs. So here's the capillaries. They're right next to the alveolar sacs. And so the blood is flowing through blood vessels lined with endothelial cells or simple squamous. So remember, surfactant is very, very important. You have to be born with that, or you have to be receive artificial surfactant, or otherwise your lungs will collapse and you'll have a difficulty time breathing, and it's not good. So normally babies are born with enough surfactant to reduce surface tension and to keep your sacs, the alveolar sacs, open. Notice we make a big point that the red blood cell and the capillary are lined by endothelium, simple squamous cells, and there's a very, very thin membrane, only 0.5 microns. And so the whole purpose is oxygen to move into the blood and CO2 to move out. Each lung has lobes. The right lung has 3 lobes. The left lung has 2. There's a cardiac notch where accommodates the heart. So the lungs' purpose is to get oxygen to the blood and get rid of CO2. Okay, if you do a cross section through a human, you'll see the heart in the pericardial cavity, and you'll have these right pleural cavities. You'll have the parietal pleura. Then you have the pleural cavity, and then you have the visceral pleura. So the lungs are attached to this visceral pleura. So as you breathe and the diaphragm goes down and your lungs expand, the lungs remain attached to this visceral pleura, and it helps the lungs expand. So when you breathe, you have the diaphragm muscle right here, and you have the ribs and the sternum. So when you first breathe in, the size in the diaphragm contracts, your lung cavity gets larger and the pressure goes down, and you, I forgot to press, no, I did record, okay. So let's stop here at this slide and go back here, and recording is working. So let's stop recording, stop.